Okay, question 5 says a hiker's trip consists of 3 segments. Path A is 8 kilometers long, heading 60 degrees north of east. Path B is 7 kilometers long in a direction 30 degrees north of west. And Path C is 40 kilometers long, heading 70 degrees east of south. Find the displacement of the vector, of the hiker, rather. Okay, you could draw it out and you could say, I'm going to do this vector, then that vector, then somehow I'm going to go from there, I'm going to go that vector and add them, tip to tail, and then draw a line and do everything to scale. Or you can just do it in component form. And don't forget, we can put all of these vectors at the origin and break them into components. And your vectors, of course, are going to have whatever your x value is. It's going to be your r times the cos of theta, where r is your magnitude of your vector, and the r sine theta would be the y component. So if you go ahead and plug those numbers in there, let me take a computer over. You end up getting this. You end up getting r1. The components are 4 and 6.9 kilometers. R2, negative 6.1 and 3.5 kilometers. R3, 3.8 and negative 1.4 kilometers. And when you add those up, the respective x and y components are 1.7 and 9. So we know that our vector is going to be in this, our resulting vector, our resultant, is going to be in that first quadrant with coordinates 1.7 and 9. So if, this is going to be roughly somewhere up here in that direction when we add these vectors. Let's go ahead and do that. So the magnitude of our resultant displacement is going to be the square root of 1.7 squared plus 9 squared. Okay, so let's go ahead and do that. All right, square root of 1.7 squared plus 9 squared. Oh, what did I do wrong here? I got to clear that. So the square root of 1.7 squared plus 9 squared, and that's 9.2. And that would be kilometers. And the angle at which your resultant vector makes with the x-axis is the inverse tan of the 9 over 1.7, and that's going to be first tan of 9 divided by 1.7, and that's 79 degrees, so almost 80 degrees. So there are your answers for that one. Okay, while we're doing this, I might as well do the one about the bird in the tree, and get that out of the way. This is actually question 4. And question 4 says, you're laying on the ground. You're laying on the ground. You're not dead, but you're just looking up at a tree. And the tree has a bird in it. It looks like a little eagle or something. But anyway, you're looking up at this bird at an angle of 25 degrees. This is not to scale, by the way. And you're 20 meters away from the base of the tree. So let's just assume that the bird is right in line with the base of that tree. And then we're going to have to say, okay, what relationship do I know? I want to get this. I want to get the height here. So I know that tangent is opposite over adjacent. Okay, so we know that the tangent of 25 is going to be equal to the opposite over the adjacent. So tangent of 25 is 0.466 times 20. So my bird is 9.3 meters. 9.3 meters, and that's how you do that one. While we're on it, we might as well go ahead and do the one-dimensional relative motion. The train is traveling 60 meters per second to the east. So we have train, and it's going 60 meters per second to the east. And we have a guy walking toward the west at 5 meters per second. So you're standing here watching the train go by. You're seeing the train go by at 60 meters per second. You're seeing this guy walk backward at 5 meters per second. So effectively, You see him moving at 55 meters per second. You just subtract the two. Okay, I'll get the other problems on here shortly.